All right, let's talk about the universe, but not the parts we can see. We're going on a hunt for the real architects of everything, the invisible forces that are truly running the show. I want to start with just one number, 5%. That's it. Kind of small, right? But what if I told you that number is, well, it's everything you've ever seen or touched or even thought about? Yeah, you heard that right. Every single star, every planet, every glowing nebula and distant galaxy we've ever pointed a telescope at, all of it, all of us, is crammed into that tiny 5% slice of the cosmic pie. It's kind of humbling, isn't it? Which, of course, brings us to the biggest question of all. What in the world is the other 95%? And this is where our mystery really begins, because it turns out the universe was not behaving the way we thought it should. Our first big clue came from a puzzle that had astronomers totally stumped. Let's call it the case of the runaway galaxies. So back in the 70s, an amazing astronomer named Vera Rubin was studying how galaxies spin. Now, Physics 101 says the stars on the outside edge should be moving way slower than the ones in the middle. But that's not what she saw at all. Her data showed the outer stars were moving just as fast. So fast, in fact, that by all rights, these galaxies should have just flown apart, shredding themselves into cosmic dust. But they weren't. And you can really see the problem when you put it side by side like this. On the left, that's what we expected, nice and orderly. On the right, that's what she actually found. It's kind of like spinning pizza dough. If you spin it too fast, the edges just fly right off. Rubin saw galaxies spinning at edges fly off speed, but somehow they were holding themselves together. So why? What was keeping them from disintegrating? This one question gave us two possibilities. Either our understanding of gravity was just fundamentally wrong, or there was something else out there, something massive and completely invisible. And that something else was given a name: dark matter. This is our first major suspect. Think of it as a kind of cosmic glue, an unseen mass that provides all the extra gravity needed to keep these spinning galaxies from flying apart. And let's be super clear about why we call it dark. It's not just dark like a lump of coal, it is completely invisible. It doesn't give off light, it doesn't block light, it doesn't reflect light, nothing. The only way we know it's there is by its fingerprints. Its gravity is so immense, it actually bends the fabric of space-time. So when light from a distant galaxy passes by, it gets warped. It's an effect called gravitational lensing. We can't see the dark matter itself, but we can see the distortion it leaves behind. Okay, so we've got our cosmic glue holding things together. Mystery solved, right? Haha, not even close. Just when we were starting to wrap our heads around dark matter, an even weirder clue showed up. The universe was accelerating. So in 1998, two separate teams were looking at distant exploding stars. For decades, everyone just assumed that the expansion of the universe was slowing down, because of gravity. But what they found was the absolute mind-blowing opposite. The expansion wasn't slowing down at all. It was speeding up. This discovery was so huge it completely rewrote the rules and deservedly won the Nobel Prize in 2011. To really get your head around how weird this is, just picture this. You throw a ball up in the air. You expect it to slow down, stop, and fall back, right? Well, imagine if you threw that ball and it just kept going up, faster and faster, shooting away into the sky. That's what our universe is doing. This was a massive problem. Gravity pulls things together. It doesn't push them apart. So there had to be something else, some kind of mysterious anti-gravity force that was actively pushing space apart. And that brings us to suspect number 2, dark energy. Now, unlike dark matter, which clumps up, dark energy seems to be a property of space itself. And here's the really wild part. As space expands, you get more space. And more space means more dark energy. And more dark energy means the expansion speeds up even more. It's a total runaway effect. So now we have our two invisible players on the field, a mysterious mass pulling everything together and a mysterious energy pushing everything apart. It all sets the stage for the cosmic verdict, an epic tug of war for the fate of the entire universe. So on one side of the rope, you have dark matter. It acts like regular stuff, clumping together, pulling matter inward to build all the beautiful structures we see, like galaxies. And on the other side, you have dark energy, this smooth, uniform force that just pushes everything outward, stretching the very fabric of the cosmos. The ultimate cosmic pull versus the ultimate cosmic push. The entire fate of our universe literally hangs in the balance of this fight. So, who's winning? The pull or the push? And when we finally ran the numbers, the answer was staggering. It turns out dark energy makes up 68% of the universe. Dark matter takes up another 27%. And that means that tiny little 5% we started with, the stuff that makes up you, me, and the stars, that's all there is. The push is winning this war. And honestly, it's not even close. So this is where we are. We've identified the main players on the board, but this investigation is, well, it's far from over. This is still the great unsolved mystery. So here's how to think about it. Dark matter is the architect. It's the invisible scaffolding that allowed all of us, all the normal matter, to clump together after the Big Bang, building the giant web of galaxies we see today. Put it this way, without dark matter, we just wouldn't be here. And if dark matter shapes the universe's structure, then dark energy shapes its destiny. This constant, relentless push is deciding the ultimate fate of the cosmos, probably driving it toward a cold, dark, and empty future where every other galaxy just accelerates away from us until they vanish from sight completely. And you better believe the hunt is on for answers. Right now, scientists are deep underground in special labs and at giant accelerators like CERN, searching for the particle that could explain dark matter. And at the same time, they're using our most powerful telescopes to figure out if dark energy is some kind of constant or if it's something else that might change over time. You know, it really changes how you look at things. The next time you're out under a clear night sky, just remember, the real story isn't in those little points of light. The real story of the universe is written in the darkness between them, and we are only just beginning to learn how to read it. And that leaves us with one last kind of unsettling thought. If the two biggest players shaping our entire reality are completely invisible to us, what else are we missing?